Hello, Digi Electronics. This is last assignment in lesson 2.1. It's project 2.1.6 AOI Logic Design Majority Vote. This one's looking back at the 2000 presidential election where there was discrepancy on who won the vote in Florida and would become president of the United States. So we're looking at building a new state-of-the-art voting machine so that everyone votes counts and no one votes counts more than another, except for in a particular company where you have a board of directors. So we're looking at a board of directors have asked you to design an electronic voting machine, and it allows 4 board members to cast their ballots, and the results will be either pass or fail. So what we're doing is we have a president, vice president, secretary, and treasurer. Each member's vote counts as a single vote of yes or no. For a decision to pass, the majority of the board members has to vote yes. In the event there's a tie, the president vote is used to break the tie. If the president votes yes and there's a tie, the decision passes. If the president votes no and there's a tie, the decision fails. So in this project, you will use AND or AND inverter logic gates, or referred to as AOI logic, to design, simulate, and build a majority vote voting machine that meets the design specifications. So you're going to use circuit design software or multi-sim. You're going to use a digit logic board or breadboard, 22 gauge wire. You're going to need a 74LS04, 74LS08, 74LS32. You're going to complete the steps to design, simulate, build, and test a majority vote machine, and you're going to document your work in your engineering notebook. So first thing you do in the engineering notebook is you're going to use the variables below and assign condition to them to create a truth table. So first thing I'll need to see is a truth table for majority vote in your engineering notebook. If you have 4 inputs, how many outputs will you need for the truth table? So that's the first thing you need to do, is draw a truth table that has 4 input and output or possible combinations, and then the output is your decision if you vote pass or fail. You're going to use the truth table to write an unsimplified logic expression for the output function decision. Be sure that your answer is sum of products format. You're going to design a AOI circuit. So you're going to draw the circuit out in your engineering notebook. I need to see you actually have the circuit drawn. And you're going to use 2 input AND gates, 2 input OR gates, 2 input inverters. Alright, when you get to multisim, you're going to test your unsimplified majority vote circuit for your voting machine. You're going to use switch inputs for P for president, V for vice president, S for secretary, T for treasurer, and a probe or LED for the output decision to light up. You're going to verify that your circuit is working as you expect it to. You're going to print a copy of your final circuit, paste it in your engineering notebook. Then you're going to use your theorem, De Morgan and Boolean algebra, to simplify the logic expression and put it in the sum of products format. After that, number 6 says you're going to design a AOI circuit that implements the simplified logic expression design and limit your implementation to 2 input AND gates, 2 input OR gates, and inverters. Then you're going to use your circuit design software to test your simplified majority vote machine. using switches for input, P for president, V for vice president, S for secretary, T for treasurer. Make sure you relabel the input switches to indicate these, so you can use the keystrokes to change your vote. Probe for LED output. Verify your circuit's working. Print a copy of your final circuit, paste it in your engineering notebook. For both of these circuits, for number 4 and for number 7, you will also turn into me a copy into Focus, so you'll upload those in Focus as well. Using the digital logic board, you're going to build and test your majority vote machine and make sure that the circuit actually is working as expected. You'll take a picture of that. You will include that in a portfolio, just like we've done in the past. The only other part to this is we're going to have a picture of the circuit, a picture of the multisim, copy of the multisim circuit, picture of that, along with a picture of the actual breadboard working. And for conclusion, as far as your summary, as far as your portfolio, you're going to write a letter. So minimum of 500 words. You're going to describe the process that you use to design, simulate, and build your majority voting machine. And you're writing this letter in the form of a letter to your grandmother, who is a retired teacher living in Florida. Assume that your grandmother is a retired third-grade teacher and has no knowledge of digital electronics. So you must explain to her what AOI logic is, steps you went through to do this. Again, 500 words to include pictures of your breadboard, pictures of your circuit design, software circuit as far as multisim, and you should also include something along the lines of a truth table that shows her what you actually did. So picture of truth table, picture of your multisim circuit, picture of the actual board, breadboarding. Make your breadboarding look nice and neat. Not a lot of wires going all over the place. By now we should learn how to design a circuit without a lot of spaghetti wires going all over the place, so that we have to troubleshoot. It's a lot simpler to troubleshoot. Alright, good luck, and that's your assignment.